Okay. Last class we did numericals from this chapter. Okay. Numericals are those types only which we had done last time. Okay, as per the syllabus. Now I'll discuss only the theory part of this chapter. Theory portion. Huh? And it's easy, and the thing which we see and which we use at home, it is all about that. Okay, it's quite easy. First topic is fuse, or you can call it electric fuse. Electric fuse. I think you all know at home you use fuse, no? Have you seen fuse there? Which you use at home?
Yes, sir.
Sometimes the inside the fuse, no, fuse there is a thin wire. Is it that is called fuse wire? Sometimes the wire breaks, wire melts sometimes, and then connection goes. If there is a very high current running and all, no? And we replace the wire by an.
This is same there in the
It's
NCV
all
also.
about that. NCB also. NCB role is same as this one. The role of fuse. NCB is a kind of fuse only. Let me tell what is electric fuse. We say it is a device. It is a device which limits the current or which controls the current. You can say that. Which limits the current. That is the correct word. Which limits. That means which will not allow the current to exceed a particular value. Suppose this device maximum current needed is 5 ampere. By chance, if the current value becomes more and flowing through the appliance will get damaged. The appliance coil and all will get burnt. So it prevents that. If you use a fuse wire of 5 ampere, then in no case the current will be exceeding 5 ampere value passing through the appliance. And the appliance will be protected from damage due to high flow of current. That is the main use of
resistor.
it acts as a resistor, yes. Yes, you are right. It acts as a resistor. Very good thinking. It acts as a resistor. It opposes the current and gets heated up. And once we know that the wire resistance should be that much so that it gets heated up and the wire melts. We use a word called wire blows. The fuse wire inside the fuse will blow, and the current will stop there only. Then the appliance is protected. So,
Blow means
what is the fuse? Blow means melt. Blow means the wire breaking. Wire melts and the wire will break. After melting, the wire will break. Isn't it? You must have seen it at home. No?
yes, sir.
Nicanor, yeah.
Yes, sir.
We can use the term technical term is blow, wire blows. Okay, technical term is that. So first question, what is the fuse? We say it is an electric device which limits the current, Okay. Now, second question, on which property of current does an electric fuse work? What property of current? We say it works on the heating property of current. Heating property. Current can do two things. Okay, just let me tell you. Current can cause two things. It can cause heating effect in a resistance. If there is a high resistance, it will produce large amount of heat. If there is a less resistance, it will produce less amount of heat. But in the fuse, we want to generate high amount of heat so that the wire breaks. So it works on the heating property of current. We say that. We don't say resistance property. It works on the heating property of current. Not the resistance property of the conductor, or the wire which we are using inside. Question talks about the current, or which heat property of current is used. We say heating
So,
property.
if heat is more, then resistance will be more.
When resistance is more, no, the more of the obstructions will be there, the heat value will be more. If you remember, last time I gave you the formula of energy formula, I gave this was IA square RT, and I have written there heat. Please check your pages or turn back some pages and see I have written it there. That means the heat produced depends upon the resistance value. More the resistance, more the heat produced. Less the resistance, less the amount of heat produced. Understand? So current flowing through a conductor can do two things. Let me tell you. Okay, are you ready to listen?
Yes, sir.
Yes, sir.
Yes, sir.
Current, yes, current can do two things in a resistance. It can cause heating effect in it, and it can cause magnetic effect. There is a magnetic effect of current. That I will be talking in the next chapter to come. That is called electromagnetism. The name of the chapter is electromagnetism. So there I will talk. The current has two effects, heating and magnetic. Okay, about magnetic effect I will discuss in the next period. I mean, next chapter. Yes, Nicanor, your hand is raised. Tell me.
Excuse me, sir.
Sir, I was just
Yes,
experimenting
yes.
with the new feature.
Okay, okay, okay. Now put it down,
Excuse me,
lower
sir.
your hand. No, otherwise. Yes.
Sir, it works on
Uh,
heating. So it works on the
heating
heating effect of the
property.
heating property of
Heating effect of the current.
heating
It
property
works
of the
on the
current.
heating property of the current. Okay? Okay, boys. Tell now, please
Yes,
respond.
sir.
Otherwise, I
Yes,
will be.
sir.
Yeah.
Yes, sir.
Well,
Yes,
Yes,
sir.
sir.
those interested boys, those good boys, those who are understanding, they should respond. No, then
Huh?
it will be
What karo?
an energy for me, no, boost for me. Otherwise, it will go
Yes, sir.
monotonous. I'm teaching one Windows and all there.
Yes, sir.
So please. Okay, now inside the fuse, we use a wire, which is called fuse wire. Now the question comes, what property a good fuse wire should have? What property? What are the requirements of a good fuse wire? We said two. There are two requirements. First one, they must be having high resistivity. The wire must have high resistivity. Fuse wire must have high resistivity with high value of resistance. Okay. And they must have a low melting point. Two requirements. Please can somebody mute your phone because it's echoing here. Please mute, it will be good for everyone. Okay. If you have question, raise hand and ask me, you are free. So I want that only. You ask me the question. A fuse wire,
High
high
resistivity and low
resistivity, low
or
melting point. Yes, low melting point.
or
And low melting point. Huh?
so for good resistance. Yeah,
For
for good
good
fuse, I
fuse
mean.
wire, good fuse wire. Inside the fuse, we have a wire there inside. Okay? And the fuse wire must have the properties of high resistivity and low melting point. Am I clear?
Yes,
Boys,
sir.
please say fast.
Yes,
Okay.
sir.
Now logic.
Yes,
Yes,
sir.
sir.
Logic, I'll tell
Yes.
you. You can think about the logic. Why it should have this property? Just think about the logic. Suppose I'm using a wire. Inside the fuse, we use small wire. No, small wire. We don't have a big fuse. We are using a small length of the wire. And if by nature they have high resistivity, so more heat can be generated by a small amount of current. So that is the reason why sufficient amount of heat should be generated so that the wire blows or wire melts. That is the reason it must have high resistivity. Second reason is why should have a low melting point? If the wire is having low melting point, it will melt quickly. I mean, the current will be stopped almost instantly. I mean, in no time. You can't wait no for the current to be stopped for longer time. Because if the current will still be flowing as current is not stopped, the appliance will get damaged. You want a quick effect. You want an instant effect, immediate effect. That is the reason why the wire must have a low melting point. Did you understand it?
Excuse me,
It's
sir.
a common sense. You can understand. Yes.
Sir,
Yeah, that's
is
it.
this is this property used in like copper wires?
No, I'm coming to that now. I'm coming to that. Good question. Listen, you are very curious. Very good. I like it. Now, the most suitable wire, most suitable material for making a fuse wire is not the copper, not copper. We use a special kind of wire as a fuse wire, and the wire is called fuse metal. Fuse metal. The wire is called fuse metal. It is an alloy. It is an alloy containing 50% lead plus 50% tin. SN means tin. This is not a general wire. Remember, it's not a copper wire because copper wire has got no resistivity. It is just opposite of this. It cannot stop current. Or you need a very large length of the copper wire to stop current. Plus, copper wire has high melting point. So it won't melt quickly. And for that reason, we are using copper wire in household wiring. So wiring it is good because wiring time we want wire not to become heated up so much. We want high current to run through it without with less obstruction, with less resistance. And they have got high melting point, and the wire can withstand the amount of heat generated in it. That's why we use copper wire at home. But that same copper wire we cannot use in the fuse because copper has got high resistivity, low resistivity and high melting point, just opposite of this, just the reverse of this. It is a big mistake. Sometimes what happens, at home the fuse blows and we replace the fuse wire with a copper wire which is commonly available at our home. And we connect the wire, we again join the wire and put it there in the board and light comes and we are very happy about it. But it is not the correct way. The role of the purpose of this one, the fuse is defeated completely. Then your fuse will not, do its role, play its role then in that case. One must not do that. Instead, one should use a special kind of wire called fuse wire. In the electrical shop, you can ask for the fuse wire and they will give you fuse wire. So, understood now? Tell me.
So what
your
will happen if we
curiosity.
use those?
Yes, sir.
So what will happen, sir, if we use the normal wire in this? So even
Normal, that's what I told you. Normal wire will have low resistivity, will not stop current, and will have high melting point. Will not melt quickly.
So that can cause accidents also, no? So if you replace fuse wire with copper wires, it will cause accidents.
Why we are using fuse? We are using fuse to protect the damage to the appliance and all, isn't it? To protect the burning of the wire and all, inside, cable and all. That is the reason we are using. But if it cannot stop current, then what is the use of fuse then? The entire purpose of the fuse is defeated. Have you understood?
Yes, sir.
Yes, sir.
Can you please understand?
Now, please mute now. Mute. Yes. So this is all about the fuse. Nowadays, this fuse is replaced by MCB, which you were talking about just now. We are using MCB now, which plays the role of a fuse. MCB. Isn't it? What is full form of MCB? Do you know what is full form of MCB? Anybody? If you know,
Purpose current breaker. Current breaker, something current breaker.
Miniature circuit breaker. Circuit, not current, circuit. Circuit breaker. Miniature circuit breaker. Why it breaks the circuit? Because it stops the current. It stops the current. It works on the same principle as this fuse meter. But MCB has got advantages and also disadvantages. In comparison to the fuse. The advantage is operation is much quicker, much faster than a fuse. It works very quickly. Almost in no time it will work. It will disconnect. It will break the circuit. Break the circuit means not it will break the wire, but it will create a gap between the two wires and the current will stop. Okay, operation is quicker. It is more efficient, but disadvantage is that it is expensive, more than this fuse metal, fuse wire. Fuse wire will hardly cost 4-5 rupees. 5 rupees you get this much wire, fuse wire, which you can time to time replace and all do that. This one is
Sir, you are lagging in my phone.
Hello.
So, in one month.
replace the manually.
Hello.
That's why they are going for it.
Hello.
So you're
Sir, you are
lagging.
lagging.
I'm lagging. Yes. Hello.
No.
No.
Yes, sir. Now.
Yes, sir.
Yes, sir.
It's okay now.
Yeah.
Sir, you're
Yeah,
still
yeah.
lagging.
Now please check. All right,
Yes,
now
sir.
tell me when
Yes,
when
sir.
it's all right, huh? Okay, thank you. Because it is not in my hand, my dear
What
one.
you're saying.
Now I'm saying MCB full form is this, and MCB plays same role as a fuse. Okay, it also limits the current. It disconnect, but its advantage is that its working is much faster than the working of a fuse wire or fuse. But its disadvantage is more expensive much more expensive than a fuse, simple fuse. Okay. So advantage, disadvantage, both it has. Understood, I suppose. Huh? Now another thing, any current related device, any current related device is always connected in series combination, in series. And it is always connected with the live wire. Live. There are three types of wire. I think you have some idea about it. Have you heard about the three kinds of wire, electrical wire? In a circuit,
Yes,
we
sir.
normally use three types of wire. What are they? Tell me.
Live wire, dormant wire, and
Mm-hmm. Live
live
wire,
wire,
right?
dormant wire,
Huh? Which wire?
wire, something like that.
Live wire, neutral wire, and earth wire. There are three types of wire. Okay, live, neutral, and earth. Earthing wire, which is connected to the earth. Three types of wire. So fuse is always connected in series with the live wire, always. Because through the live wire only the current enters. Okay. Stop. Current exists through the neutral wire. So to
Again, repeat again. What did you
the
say?
wire fuse is connected. Yes. Huh?
Sir, wire.
Can you repeat again? You were lagging.
So you were lagging.
Hello. Okay. Fuse is always connected with the live wire in series. Fuse is always connected with the live wire in series. Understood? Finish? Okay. So this is
Yes,
all
sir.
about the fuse.
That fuse is always connected.
Connected with the live wire.
Hello. Hello.
Hello, we can't hear. Hello.
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 Okay, with the live wire in series. Understood? Okay?
Yes, sir.
No, the topic of fuse is done. Huh? Okay, any question in your mind you have? You can share with me. I think understood, no? Should we use
Yes, sir.
copper wire in fuse?
So what is the
Okay.
use of live, neutral, and earth wire?
Through
Earth is used for
through the
earthing.
live wire, wait. Through the live wire, the current enters. Okay. And through the neutral wire, the current exits and goes back to the source. Suppose one example,
What wire?
suppose we are having neutral wire, neutral. Suppose here is a battery and here is a some appliance. Appliance will have resistance. We normally write it as resistance here. Okay, this is kind of appliance. From here the current will start. Current enters. This will be the live wire. This can be taken as a live wire. Through the live wire the current enters, and through the other end the current returns back to the source from where it is coming. You need always three wires. No. Wait, I'm talking about arc wire later on. Okay.
Okay, sir.
With the two wires, the bulbs and all, no, you must have seen bulbs, your fans, your tube lights. With single wire, will they glow? Will they work?
No, sir.
Single wire,
No,
Okay.
sir.
No,
it
sir.
doesn't work. So you need two wires. Through one, the current will flow, and through the other one, it goes back to the source. Then only the circuit is complete. If this wire is not there, the current cannot go back. The current will not run only. So you need minimum two wires for the flow of current. Understood? I am doing one by one. Please have patience. I will tell you everything. What is there in your mind, I will tell you. But Dakshit is very ambitious, so he wants to know everything at that time only. I'll tell you. Don't worry.
What?
Understood?
Sir.
Yes, understood or not, boy?
Yes, sir.
Yes, sir, understood.
Where should we use the fuse? Fuse, we must use it here. And fuse the function and the symbol we show like this. This way we show. This is called F. F is fuse. This one. This is the symbol of resistance. This is the symbol of fuse, and we can write here F. Just to show a wire like this, because this wire will break here. Once the wire breaks, current cannot go to the appliance. This is appliance. This one is your appliance. Current cannot go through the appliance, and now appliance is safe. So, to which kind of wire the fuse is connected? We say to the live wire. By chance, we are connecting in the neutral wire here. Just see, we are connecting the fuse here. Somebody who doesn't know and connecting the fuse wire with the neutral wire. This is neutral, no? This side is live. Now see what is happening. The current will be passing through the appliance. Current will pass through the appliance, and then here it will break. That is, appliance is already receiving the high current and it's getting damaged. What is the use of fuse then? What is the use of fuse? Fuse is a protecting device. Did you get my point, guys? You understood?
Yes,
So
sir.
then sir, it'll have something neutral. If the fuse is placed in the neutral wire, then the appliance will only get current and go back. No.
Damage cannot be prevented. You know, appliance will get damaged. Due to flow, this current coming, still here it is coming. No, and appliance is already receiving current. We don't want high current to be received by the appliance. This is the reason why we are using a fuse. We are protecting it, the appliance, and we are preventing its damage. That we cannot do if you connect the fuse in the neutral. Done? Understood or not? Tell me. Okay.
Yes, sir.
Now,
Can we divide the, sir?
Can we?
So this light, yes, sir. So
Can you?
the light point.
Vinayak, please.
Sorry, listening.
Okay. No.
So the
any
light
question
point
you had
for
in your
the
mind?
series combination. No? Yes, sir.
It is
So
in
can
series,
we?
because can we?
So can we make it in parallel afterwards?
If you connect in parallel, no. Wait. I'll tell you. If you connect in parallel, so only the current will be stopped in that particular line only. Other lines current will still be flowing, because in parallel what happens? See, this is called parallel. Like this one is here. This is parallel combination. No, this is parallel here. If you are connecting a fuse here like this, If you connect a fuse here, you're connecting a fuse here, and here is an appliance which is receiving like this. This is negative. This may be live. This will be neutral like this. This is neutral, suppose. We are connecting one fuse here, another fuse here. This fuse blows, so only this appliance is protected. Here the high current is coming, current divides. But if you connect a fuse here, so only this appliance is only protected. What about the other appliance? Other appliance is still receiving high current. No, current is still coming here and passing through them.
Why not putting?
You understand my point?
Why not putting?
So we can put what
Yes, sir.
fuse over there.
On both the appliances.
Then, if you want to put a fuse here also, here also, you can do it. But it is more expensive, no? It is more expensive and it is more tedious.
5 rupees more.
Isn't it? So you must have seen at home sometimes we use the main switch. Have you seen a switch? Main switch, no? Or MCB, it's all the same actually. The rule is
yes,
same.
sir.
What is the main switch? Main switch, once you put it down, entire house, the current will not flow.
Electricity gone.
Electricity gone. Yes. Everywhere, isn't it? And you want that. Am I right or wrong? Sometimes you do some repair work.
Yes,
Some wire is broken, maybe some appliance is broken and all, and you want to put off the entire system. You don't want any current, otherwise when you touch it, you may get a shock. So you pull the main switch down so that the current is off completely. And now it is safe to do the repairing work. Am I right or wrong? Tell me.
Yes, sir.
Yes, sir, you are right.
Yeah, if you connect the fuse in any particular this one, so only that appliance is not receiving, but other current is still running at home. So that will create a problem.
So in household
I think
also that
understood.
series. In household, series is used and not parallel, no?
Now see, each appliance has its own fuse also. Costly appliance, they are having inbuilt fuse. Company will put a fuse. Like for example, we got a television set, TV set. TV set is very expensive. You know that, no? 20,000, 25,000, 30,000. This costs this much. And by chance, due to high current, if it gets damaged, it will be causing the damage will be quite big. So inside the TV, and all these kind of expensive devices, they will have a fuse inside. That fuse will be in parallel because it will protect only that device. It will protect only that device. Did you get my point?
Yes, sir.
Yes, sir.
Yes,
So,
sir.
Yes. Tell me.
So can we put a
Can
switch
we?
directly on the live wire? So can we put a switch directly in the live wire?
Switch is also placed in the live wire only. You can't put in the neutral.
Like fuse?
Switches, fuse, these kind of devices, anything, because what is not coming to that switch only, After this, the next topic is switch. Switch is always connected in series, same as this one, in series with the live wire only. Switch is on and off device. When you switch on, then through the live wire current it starts entering. Understand? And when you want to put it off, switch off, then current is stopped here only. The device is not receiving any current. The appliance which you are using is not receiving any current. Switch is also connected in series and with the live wire only, with the live, like this fuse and all. That's why I told you in the beginning, any current related device is always connected in series. Like ammeter measures current, always put in series. Fuse, it limits current. You have to always connect in series and with the live wire. And just now I told you about the switch. Okay, boys. Yes, boys. Your questions I'm enjoying.
Yes, sir.
Very good. Okay, you also do the same. Yes, interact. Very good.
Okay, sir.
Okay, now I'm coming to the next topic. So I tell Dakshit, I will answer all your queries. Okay, let me tell myself first, and then you ask me the question if you don't understand. Okay. Switch. Next topic is electric fuse. Is that all understood about electric fuse, no? Boys, have you understood everything about electric fuse?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Sir.
Okay, thank you. Thank you, thank you. Now next topic is switch or switches. Okay. We say it is an on-off device. It allows us to use the appliance as per our desire, as per our requirements or as per our desire. We want fan to be on. We are using a switch. You are switching on and you are having the fan working. And you don't want the fan to be working. You put it off. So as per your requirement and as per your desire, the switch is an on-off device. And as I told you, it is always connected in the series with the live wire only. Okay, nowhere else. Okay, now another thing. What precautions one should take while handling the switches? Because switches that we are touching, no?
And should not be wet.
Yes, hand must not be. The switches must not be touched with wet hands. Your hand must not be wet while touching the switch. Because your wet hand will have water through which the current will be conducted to your body and you may get a shock. And switch must not be touched with the bare foot. One should avoid touching the or switching on and off barefoot. Because earth is a very big conductor. Yeah.
Yes, sir.
So one should be wearing some kind of, insulating slippers, shoes or whatever, something should be there. It should not be barefoot. Another one, switches must be tightly fitted. Switches must be tight. There should not be any loose wiring in the switch. Switches must be fitted tightly on the board. Where we are having the switch, the board must be the switches must be tightly fitted on the board. Your switch should not be hanging here and there because there is a chance that, mishandling may give you a shock. And you can say, all common sense. And you can say this also, that a switch must have a proper rating depending upon the current capacity of the appliance. You must use, sometimes we use, at home you must have, sometimes use big switch, sometimes use a small switch. We don't use a single, same size switch for all. We must have observed it. Heater, geysers and all, like high current consuming device, we are using big switch. And their ampere rating is higher. Current rating is higher. They will have a switch of 16 ampere, 10 ampere, this kind of power switch. We call it power switch. Big inside. You must have seen it. Have you seen it at home?
Yes, sir.
Power switch, big one.
Yes, sir.
And for fans and all, we need only 5 ampere. Small switch will do. Small switch because we are not high current consuming device. So you must use the proper rated switches. Okay. So we are ending up till here. This switch I taught. Now little bit only left. Now next class I'll finish that and start new chapter, electromagnetism. Okay. Thank you, boys. Only little bit left now. Next time I'll talk about what. Next class I'll talk about urging. Yes. Thank you, boys. Thank you very much.
Bye, sir.
Bye, sir.
Sir.
Bye.
Tata, sir.
May God bless you.
Tata, sir.
Same to you all, boys.